Hello Year 7, today we're going to start a new module all about energy. Now energy can be described as work done. So if ever you see this term, work done, you know that that's another way of talking about energy. Now before we look at all the different types of energy, you need to know the unit. The unit that we use for energy is joules. And it's represented with a little j. Now 1,000 joules is called a kilojoule. So 1,000 joules equals 1 kilojoule. A bit like how 1,000 meters is 1 kilometre. Okay, the word kilo means 1,000. And if we don't want to write this out in full, the symbol for kilojoule is kj, little k, little j. All right, just want to pause the video and write this down, then feel free. Now then, there are 8 different types of energy that you need to learn. So if we write energy here, and we do a spider diagram, let's write about all the different types of energy that we can think of. So the first one that I can think of is light. So that could be the sun, it could be a light bulb, it can be the light on your mobile phone, it could be a torch. Okay, so anything that actually emits light. The next one I can think of is sound. Sound energy. So it's the energy I'm using to talk to you now. It's a dog barking, an aeroplane up in the sky, a car horn. Okay, so it's sound energy. The next one is thermal energy. Now that's the posh way of talking about heat energy. So instead of saying heat energy, we say thermal energy. The next one I can think of is movement energy. And again, we have a word that you need to use in science to describe movement, which is kinetic energy. So let's put movement, and then in brackets, kinetic. So that's an object falling to the ground, is a car moving, a horse galloping, me now writing. This is all movement energy, a ball bouncing. All right. Okay, next one then. Electrical energy. So that's the energy that's used to make your washing machines work, your dishwasher, your television, your computer, your iPad. Electrical energy. Right, so how many have we got now? 1, 2, 3, 4, 5. Okay. So the next one, chemical energy. Now chemical energy isn't just about chemicals that you get in a science laboratory. Food is chemical energy. Okay, food has got chemicals in it that we then digest, and that allows us to have energy in our bodies. Any kind of fuel like petrol or diesel or oil or coal or gas, they're examples of chemical energy as well. Okay, a bit of a strange one for you now. Potential gravitational energy. This is the kind of energy that anything that's above ground level, okay, and has the potential to fall, that's what we say has potential gravitational energy. So for example, if I was to stand on the table, I could fall, couldn't I? So I've got potential gravitational energy. If I lay on the floor, I can't fall anymore. So therefore, I have no potential gravitational energy. Potential gravitational energy. And there's one more, and that is elastic energy. Now this is the energy that is stored in a bow and arrow. If I pull back the bow, that tension, okay, there's loads and loads and loads of energy stored in that bow, isn't it, before I let it go. Ping! If I was to wind up a wind-up toy, the tension in that spring before I let it go has got elastic energy in it. So, elastic. Okay, so let's just count them up. We've got 1, 2, 3, 4, 5, 6, 7, 8. 8 different kinds of energy that you need to learn for me. Now, just one last thing, and that is these last 3, chemical, potential gravitational energy, and elastic. I'm going to star these because we say that they are stored energy. Okay, so can I fit this in, I wonder? You see that? No, you can't. Okay, let's put it up here then. So the star means stored energy. Okay, stored energy. So we can store chemical energy, we can store potential gravitational energy, and we can store elastic until we want to use it. So for example, until I set fire to petrol, the energy isn't released. Until I digest my food, the chemical energy isn't released. Until I actually push a ball off a shelf and it falls, the potential gravitational energy has not been released. Until I actually let go my bow and arrow, the elastic energy has not been released. So these 3, chemical, potential gravitational energy, and elastic, are the 3 examples of stored energy. Okay guys, so we've learnt that another term for energy is work done. We've learnt that the unit for energy is joules. We've learnt that 1,000 joules is a kilojoule. And we've learnt that there are 8 different types of energy: light, sound, thermal, movement, electrical, chemical, potential gravitational, and elastic. Okay, now then, there's one more thing that I'd like you to learn from me today. And that is this little rule here. It's called the conservation of energy law, or the law of conservation of energy. Okay, so what do you think the word conservation means? If I said, I really want to conserve the pandas, I want to conserve all the extinct species in the world, what would the word conserve means? Well, it means to save. So this here is the law of saving of energy. So all the energy on the earth, every single type of energy originally comes from the sun. And I'll show you how that is in one of our next lessons. Once the energy from the sun reaches the earth, it cannot be made or destroyed. It can only be turned from one type into another. Okay, so let's write down the law and then I'll show you a few examples. Energy cannot be made or destroyed. It can only be turned or be changed from one type to another. Okay? All energy comes from the sun. Okay? So energy cannot be made or destroyed. It can only be changed from one type to another. And the other thing that you need to know is that all energy comes from the sun. So I just want to show you one or two examples of this happening. Okay, so excuse my artwork, but this here is a washing machine. All right, a washing machine. So to get the washing machine working, we put electrical energy in, don't we? Electricity. Okay. Now, what kind of energy does the washing machine turn the electrical energy into? So we have sound, because washing machines make a lot of noise, don't they? We have heat. Now, some of that's useful and some of that isn't, depending on if we want to do a hot wash or not. And finally, kinetic energy. Okay, the energy that moves the drum around. So not all of these energies are going to be useful, are they? Kinetic is useful, we want it to move. Heat might be useful depending on if we want a hot wash or a cold wash. But sound really isn't useful at all, is it? It doesn't matter if our washing machine's noisy or quiet, really. In fact, we'd probably prefer it if it was quiet. So we say that sound is a wasted energy. Okay? So all this electrical energy, it's not made, it's not destroyed, it's literally just turned into sound, heat, and kinetic energy. Okay, let's do another one. Okay, so we have an apple. So do you remember this is chemical energy? Okay, because it's food. And remember that chemical energy was one of the examples of stored energy, wasn't it? The energy doesn't get released until we digest it. So we have chemical energy, and then we eat it and we digest it. And what is that chemical energy going to turn into? Well, some of the energy from our food turns into thermal or heat, keeping us warm, doesn't it? Some of it will come from sound, because we're quite noisy, us humans. And also, it will be to help us move, won't it? Kinetic. All right, so again, the chemical energy isn't wasted. It gets turned into thermal, noise, and kinetic energy. Okay, so that's the law of conservation of energy, that it cannot be made or destroyed, just turned from one type into another. Okay, everybody, we're going to leave that today. So I want you to have a look at our page, and I'm going to set you some work, okay, for this lesson. All right then, take care everybody, bye.